All right, so let's work some specific problems so you'll know how to move through your homework practice for this time. So there were some questions about this online when people were logged into the classroom. Expect a new video lesson every other day. So that gives you maybe a day to do video lessons and the next day to do practice and then the next day for a brand new lesson. Or you could do the video lesson and the practice all in one day, take the second day completely off from math, and then the next day start up with me again. So y'all can arrange that how you want, okay? But I'll meet you online every day if you want to log on and ask for help over anything I've done in the notes, or as you're trying to do the practice, if there's something you're not getting, please log on and just ask, okay? The other thing I wanted to mention is we realized on Thursday that it might be better to separate a little bit further on our times. So I'm going to have second block's time slot moved from 11 to 11:30 to 12 instead of 11 to 11:45, and that way I'll split up you all in fourth block. All right, so when I look at this first problem, we're going to hopefully do the same thing on every problem, and you're going to feel okay with it. That's the goal. All right, so on the first problem, I recognize because it's got the x minus 4 squared in the equation, that looks like vertex form. So I just want to get used to looking at that, okay? This parabola opens up. I like to draw a little example rather than writing the word up, just because that way when I have the big graph, I make sure when I look back at my little tiny thumbnail sketch that they look alike. I need to find the vertex. Now, let me say, it might be helpful for you to say plus 0, my bad, plus 0 out here on the end. And then the x minus 4 squared part, when you're looking at vertex, this part, I'm going to color code if I can get this moving. This part tells you that the vertex's x coordinate is 4. And then this caboose tells you that the vertex's y coordinate is 0. All right? So since we got vertex form, vertex is super fast. There's not any work. We love that. Now, the axis of symmetry, remember, is the vertical line x equals your x coordinate of your vertex. So that's way easy to do, okay? So if I'm graphing, this is where I am in the problem at this point. I could say, well, I'm going to go to 4, 0. So I'm going to freehand just like you all would be doing. So when I go to 4, 0, it's going to be 1, 2, 3, 4, 0. I know the parabola opens up from there. So the parabola is going to do this, but I don't know how wide to make it. So I will go back and I'll fix that a little bit better in a minute. But I do know that the axis of symmetry is the vertical line x equals 4. So that axis is going to cut from the vertex or through the middle of the vertex. And I'm drawing it only upward so that the parabola can spread out upward on either side of the axis of symmetry. So on this one, now I'm going to start my counting. So my A value is 2. So remember, normal means count out 1, up 1. That's your normal count. That's if A equals 1. We always have to know what's normal so that we can do the adjustments in A more easily. So on this parabola, I would count out 1, and I have to double the up count. So I have to double 1 and say up 2, because I know that this parabola is supposed to be a little bit tall and skinny. It won't be as tall and skinny as if the A were like 5 or if the A were 10. Those would be super tall and skinny. So I'm going to simply go out 1, up 1, out 1, up 1. You all know my computer does some weird stuff. And guys, if I plotted more points, I'd have even a better looking parabola. but I'm going to let you get away with 3 points and call it a day, okay? So, especially when you're working on My Math Lab, you need to plot, you need to choose your parabola tool, you need to plot the vertex, and then it'll have you drag from the first vertex, from the first point, which is the vertex, to your second point. And once you stop it at either one of those 2 points that I just drew, it makes a perfect parabola and you can stop anyway. Now, I want to mention one more thing. It asks you sometimes about the maximum or minimum value of the parabola. So let me address this guy down here, the max or min. So for my parabola, the max or min, by the way, is always vertex. So since my parabola is right side up, this vertex is equal to my lowest point on the whole parabola, and low points are called minimum. If it was a high point, you'd call it a maximum. So they're either going to want you to type in that the minimum point is 40, or if they ask you specifically for the min value, and we'll have to play and figure out which one it wants. Sometimes if it wants the minimum value, it really just wants the y coordinate. So you would say the minimum value is that lowest y value, which is the 0 of the vertex. Usually when I ask that question, I actually want you to write the whole point, but we need to double check on My Math Lab. Now, on this one, do you recognize that the parabola is in the standard form? Because I'm seeing ax squared plus bx, plus c, I could always add in as plus 0 if that bothers you that it's not there. Okay, this parabola opens down. How do I know that? Because it leads off with a -2. So your a value is a -2, and that's what makes me know I'm going to count out and down and not out and up. Now, vertex you can't just see, so we're going to have to do the work on this one. And the formulas I gave you said, first find x using x equals -b all over 2a. So -b is -16. 2a is 2 times -2, which is -4. Well, that reduces to x equals 4. Now remember, any time you've got an x and you need the y that goes with it, you plug x in, get y. So I'm going to say now y equals -2 times 4 squared plus 16 times 4 plus 0, which I'm not going to actually put. So that's -2, 4 squared 16, you got to square before you multiply. 16 times 4 is 64. -2 times 16 is -32 plus 64. And 64 minus 32 is 32. Whoa, gosh, that's going to be like really kind of hard to plot. So now the whole vertex is equal to 4, 32. All right, so what I might need to do on this is I could scale anything I wanted to on the x's because I could go to x equals 1, 2, 3, 4. But on the y's, I think I need to scale a little differently. So let's do this. Now you're not going to have numbers this big, I don't believe, on My Math Lab either. But I'm just going to scale this 1, 2, 3, 4 like normal. And then let's see here. How about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Nope, I better scale by 4s. So 4, I was going to see if I could scale by 2s, but I don't think so. So 4, 8, 12, 16, 20. 4, 8, 12, 16, 20, 24, 28, 32. I believe that's the best I can do. So 4, 32 is going to put me right here. Now, I know the parabola goes down from there. And I know, guys, remember, the axis of symmetry is just the vertical line that uses the x coordinate. So the vertical line x equals 4 is going to be like this. And I'm going to make it cut downward from the vertex because the vertex opens upside down. Now, actually, on this too, I need to go whoop I'm not going to count out and up. I'm going to count out and down. So I fixed that. And we're going to do exactly what we did last time. The last time we counted out 1, up 2. So this time we're going to count out 1, down 2, because I've got the same basic A value. So out 1 is here. Down 2, though, would be down to 30, not down to 28. So make sure that we're remembering that we've scaled by 2's or 4's on the y-axis. Now, here's something else you can think of. If you have A equals 1, remember that's normal. Okay? Normally, you also go out 2, up 2 squared, which is 4. Okay? So on this one, we could say if we go out 2, we're going to go down not 4, but 2 times 4 is 8, because I'm multiplying on my normal up-down movements by 2, because A is 2. So I could go out from the vertex 1, 2, down 8, and down 8 would be 2 full tick marks. So out 1, 2, down 4, 8. So that would give you an easier point to plot. Guys, this problem is going to be harder, though, I think, probably because of the scaling, than anything that you'll see on my math lab. So on my math lab, if you're asked for a maximum or a minimum, do you all see on this parabola that my vertex is the highest point on the parabola? So I'm going to say it's a max, and we already know the max is at 432. So some of the problems might just ask you, does this parabola have a max or a min, and what is it? So once you figure out that the parabola is right side up or upside down and you know the vertex, you can answer that question and move on. All right, so take a look at this one. I'm going to start from the top. The form is vertex form. I hope you're getting better at doing that. This one opens down because do you see that the A value is -1? The A value is the number that comes right after the equal sign and right before the x plus 5 squared part. Vertex I can just look at. So remember, the x plus 5 part tells me that it would be -5. And if you're like, yeah, but it's supposed to be x minus h squared. Remember, x minus a -5 squared is x plus 5 squared. So that's how I know. What you basically do, if it's x plus 5, the vertex is negative. If it's x minus 5, the vertex is positive, the x part. Now, on the y part, the caboose tells you that your y coordinate is -3. So the x's always feel like, to me, they go backward of what feels like my gut's telling me, but the y's go right along with what my gut tells me. The axis of symmetry is just x equals whatever your x coordinate of your vertex is. So the axis of symmetry is never extra work. Okie dokie pokies, here we go. I'm going to plot this parabola quickly. So I need to go to -5, -3, and make room to go upside down. So you'll notice that whenever I do these personally, I just draw the part of the graph I need. I don't draw the whole coordinate plane. So 1, 2, 3, 4, 5, 1, 2, 3. So there's my vertex. The parabola opens downward. So x equals -5. I'm just going to draw the part of the line that goes downward from the vertex. Now, since my A value is -1, I go out 1 and down, not up, 1. Okay? Because this is a normal shaped parabola, it's just upside down. So I don't need to change my counts, I just need to change from up to down. So out 1, down 1, or I could say, well, out 2, down 4, because 2 squared is 4, out 2, down 1, 2, 3, 4, out 3, down 9, because 3 squared is 9. I'm not going to do all that. Remember, I'm only asking you to do 3 points, so you could have done these first 3 points and stopped. And again, that way it's like what you're doing on my math lab. So on this one, do we have a max or a min? I'm saying that we have a max And I know the max is the vertex. The max is -5, -3. That's what I would say. Now, again, it could be that if they say what's the maximum, you say -5, -3. If they actually say the max value, it could be that what they want you to do is just name the y value of the vertex. We'll see how my math lab is set up for you all, okay, because sometimes that varies depending on the question. All right, so I'm looking at this one and I see that this is in standard form. I immediately see that my a value is 3. That means this parabola opens up because 3 is positive, not negative. I expect this parabola is going to be tall and skinny because 3 is larger than 1. On the vertex, I can't see it right off the bat. I have to do the work. So remember, if you look at your notes, it says if you have vertex form, you've got to start with x equals -b all over 2a. So I'm going to start there and say, oh yeah, -b is -12. 2a is 6. So that's giving me x equals -2. If I have the x and I need the y, I plug in. So 3 times -2 squared plus 12 times -2 plus 8. That's going to give me 3 times, -2 times -2 is 4. 12 times -2 is -24 plus 8. So I've got 12. 12 minus 24 is -12. -12 plus 8 is -4. So I'm saying that my whole vertex is -2, -4. Oh, thank goodness this one doesn't have such large numbers. Hey, remember, the axis of symmetry is x equals whatever the x coordinate is. So x equals -2. Axis of symmetry is no biggie squeaky. Don't make it harder than it needs to be. Okay, so -2, -4, and opens up. So I'm freehanding right along with you. You can obviously get a straight edge, but probably you're not going to need one. So -2, -1, 2, 3, 4. That is the beauty of graphing on my math lab, is that your graphs are perfect without needing a straight edge. All right, so I know my axis of symmetry is going to run upward from the vertex since the parabola is right side up. Now, I'm going to count an a value of 3. All right, so remember, a equals 1 is normal. Normal means go out 1 from the vertex, up 1. Well, I'm going to go out 1, up 3 times what's normal. So I'm going to go up 3 from the vertex. So out 1, up 1, 2, 3. Out 1, up 1, 2, 3. This quick sketch thing is going to work great for you as long as your a value, I'm going to try to do that a little bit better. As long as your a value is 1 or any other whole number. The a value only gets tricky when it's a fraction. Otherwise, I expect y'all to use the a value like gangbusters, and we'll work on the fraction stuff. All right, so oops, one more thing. Is the vertex in this case a max or a min? I say it's a min. So if all your ask is max or min, you're going to say min. What is the min? It's the point -2, -4. If it just wants minimum value, then you might just say the minimum value is -4, the y coordinate. All right, whoa, holy moly, look at this. On this one, I'm giving you an inequality. Okay, don't worry about the inequality until we graph. All right, it changes nothing on everything else we're doing. So I'll get there when we get to the graph. All right, the form of this one. Now, this one's doing double duty, okay? Let me show you. You can look at this two different ways. I'm going to use the equation here. You can either say y equals 3 times x minus 0 squared plus 1, which makes it look like it's vertex form. If you look at the equation like it's y equals 3x squared plus 0x plus 1, then it looks like you're writing it in standard form. So every now and then you have one that's a crossover. So generally the ones that are crossover are the ones that have the x squared term, but they don't have an x term. If they don't have an x term, then you could look at it as vertex or standard. Now I'm going to tell you, I think standard's the easier way to go. So you can work with it as if it's in standard form, but vertex form, I don't know if I just said that backward. I'm sorry if I did. Vertex form's easier. This guy opens up because we've got an a value of 3. The vertex I can just look at if I look at it in the vertex form way I've rewritten it. So that would say the vertex is at 0, 1. And the axis of symmetry is at x equals 0, the x coordinate, remember. All right, so what do I know now? Well, I need to make room to go to 0, 1 and make the parabola open up. So 0, 1's right. Big dot theorem. You know how this board is. It doesn't always graph right like I want it to. The parabola opens up, so I'm going to make the axis of symmetry run upward from the vertex. Now, the a value is 3. We just did that, and we said on the previous problem that if your a value is 3, you count out 1 up 3. If the a value was negative 3, you'd count out 1 down 3. But there is no need to switch from that last problem to this problem, so I'm still going to go from the vertex out 1, up 1, 2, 3, or out 1, up 1, 2, 3. And again, once you know that one of those points is 1 unit from the red axis of symmetry, they both are. Now, we've got to pay attention because before I graph this, we've got to look at the fact that we have an inequality. If you have an inequality, before you graph, you have to decide, is it dotted or solid? And then you also have to shade it, okay? Otherwise, this is exactly the same. So I'm looking at it and I'm like, okay, this thing is solid because the graphs that I graph dotted are just greater than graphs or just less than graphs. If it's an or equal to, whether it's greater than or equal to, less than or equal to, it's solid, okay? Now I've got to say, well, where do I shade this thing? So when I'm shading, what I want to do is remember that less than means below. So if I go to my vertex and I go below my vertex, I'm outside the parabola. So in this case, I'm going to shade the whole entire outside of the parabola. So when you do less than greater than, go above or below the vertex, and then shade either the whole inside or the whole outside of the parabola, depending on the picture. So the inequality part's like easy. All right, so take a look at this one. Oh my gosh, it's another inequality. Guys, the inequalities don't make it more difficult. You just need to remember that. So I'm totally going to ignore the inequality part until I get to the graphing. So do you all see that this guy is in vertex form? Yippee! Those are the best. This thing opens up because your a value is positive. And because it's a fraction, I'm expecting this guy to be shorter and fatter than normal. Okay? Since it's vertex form, I look at this and go, okay, x minus 2 squared means x equals 2. That's that first part of the vertex. I look at the caboose. The plus 7 tells me the y-coordinate of the vertex is 7. I also know that my axis of symmetry is just x equals whatever the x-coordinate is, so it's 2. So what I need to do is start my graph. X equals 2, 7. The vertex is 2, 7. I need to make room to go all the way up to 1, 2, 3, 4, 5, 6, 7. So 2, 7 will be here. This guy opens up So I'm going to make my axis of symmetry extend above the vertex. All right, so we've arrived at the hard part of the problem, and that is, how do you count 1/2 on the A? So again, I'm going to keep going back to normal. A equals 1 is normal. In a normal parabola, you count out 1, up 1 squared is 1. Or you count out 2, up 2 squared would be up 4. Now, if I'm going to take half, it's easier to take half of 4 than it is to take half of 1. You might be going, what? Where's she getting this? All right, look. I can take half of 1, but that's messy. I could also take half of 4. This is easier. So I'm going to do the out 2, up half of the 4. So I'm going to go up 2 from the vertex, and that makes this guy a little shorter. So from the vertex, I'm going to go out 2, up 2, out 2, up 2. All right, so now I remember that this thing is an inequality. So should I go dotted or solid? All right, guys, on this one, since it's just greater than, it's dotted. So I'm going to draw my parabola dotted. Now, the next thing I have to do is shade. And y'all remember that greater than means above. So if I start at my vertex and I go above my vertex this time puts me inside the parabola. So shade the whole inside of the parabola, and you are done. Let's knock out these next two problems. Hopefully you're feeling all right with this. Okay. So my form on this one is vertex form. And let me remind you guys that you can always rewind the video if I'm talking too fast, or you just need to pause and write some stuff down. Use that to your best advantage. All right, do you all see that this thing opens down? Why would that be? Because the A value is negative. Uh-oh, the A value is a fraction again, so I'm expecting a short, fat parabola, and I got to figure out what to do with the A value. Yikes. Okay, so vertex. The x plus 6 part tells you it's -6, comma. Take a look, guys. There is no plus anything out here, so if I wrote +0, then it would make sense to me that the vertex is -6, 0. I know the axis of symmetry is x equals -6, just the x coordinate. So here we go. Let me go ahead and plot what I know. And I've got -6, 0, and I need to open down from there. So that means really I can think ahead and realize I really just need the third quadrant. So -1, 2, 3, 4, 5, 6, 0. And I need to open down from there. So my axis of symmetry is going to extend from the vertex downward. Okay? Now, let's go over how we figure out the other 2 points to put in the parabola. So here we go again. Normal is when A equals 1. I'm trying to get you to connect all this stuff that we can put together. If you normally step out and up, you're going to go out 1, up, or in this case it would be out 1, down 1. Okay, you could also go out 2, down 2 squared is 4. You could go out 3, and down 3 squared is 9. Okay, I've got to take a third of whatever I do. Well, taking a third of down 1 is messy. Taking a third of down 4 is messy. But taking a third of down 9 is doable. So I'm going to say I'm going to count out 3 and down a third of 9, which is 3. So from the vertex, I'm going to count out 1, 2, 3, down 1, 2, 3. And again, since this is 1, 2, 3 from the red line, 1, 2, 3 from the red line on the other side. Okay, hold on. Don't graph yet. Is this parabola dotted or solid? Because I'm seeing that it's an inequality. All right, I hope you said already, dotted, Ms. Porter. It's dotted because it's not less than or equal to. So there's my parabola. And so now I've got to figure out where do I shade. And when I'm looking at this, I'm seeing less than means below. So I go to the vertex, I go below the vertex, and again, this time below also puts me inside the parabola. So that means shade the entire inside of the parabola. Pretty all right. By the way, I think I skipped this on the last problem. On the max or min, remember, since the parabola is upside down, our vertex is a max. So you could say the max is negative 6, 0. On the previous problem, our vertex was a min if it asks. You don't normally have to say max or min. It's just if it asks that question. On this one, our vertex was a min. So I kind of started glossing over some of that because most of the questions don't ask you about max or min. Just a few of them do. Okay, so it's not a typical thing you need to answer. All right, here we go. Last problem. So our form on this one is good old standard form. It's pretty straightforward. It opens down. Why does it open down? Because the a value, the number before x squared, is a negative 1. Okay, so standard form makes the vertex difficult. So I have to say x equals negative b all over 2a. So negative 6 all over negative 2. Are you seeing that x reduces to 3? Now if you've got an x and you need the y that goes with it, you plug in. So it would be negative 3 squared plus 6 times 3 minus 10. So that's negative 9 plus 18 minus 10. And that's going to be negative 19 plus 18 is negative 1. So I say the vertex is at 3, negative 1. Axis of symmetry is x equals whatever your x coordinate is. So remember, axis of symmetry is never extra work. So you got to like the axis of symmetry. So I need 3, negative 1 for my vertex and upside down. So I need to put more room below the vertex than above. So 3, negative 1, 1, 2, 3 is going to be right here. My parabola opens down, so I'm going to extend my axis of symmetry downward. Okay. Now, the a value is negative 1. The negative part makes you count down, not up. Okay. But it's still 1, so it's out 1, down 1, or out 2, down 4, or out 3, down 9. So it's your normal series of steps from the vertex. So I'm just going to say out 1, down 1, out 1, down 1, or you could do out 2, down 1, 2, 3, 4, out 2, down 1, 2, 3, 4. Or if you want to be really fancy, out 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, so 1, 2, 3, 1, 2, 3. You don't have to draw all those extra points. I'm just reminding you. So before I graph the parabola, since it's less than or equal to, make it solid. Let me try that again. Got it. I'm going to say this right now before I forget. This point's a max. If it asks you for a max or min, state that it's a max because it's the highest point in the parabola. Now I need to shade it. And it says less than or equal to. So again, I've got my parabola. I'm going to move below because it's less than. And since that below point was Inside the parabola, shade the whole inside of the parabola. All right? So I think we've got everything done. Be careful. There's one thing on my math lab that sometimes messes people up. Some of the problems ask you to graph the parabola only. Some of them ask you to graph the parabola and the axis of symmetry. So just double check the reading part of it, because if it doesn't graph the ask you for the axis of symmetry and you put it in there, it'll count it wrong. Or if it asks for the axis of symmetry and you leave it out, it'll count it wrong. So just real carefully read the questions, because you might be doing it right and just mess it up. So I'm going to do one thing. I'm going to make sure that was upside down and below. That was right side up and above. That was right side up and below. Okay, so I was just trying to make sure that I had shaded correctly on all of these because I wanted to give you a good variety. All right, I will talk to you again 2 days from now.